Hi, I'm Emmanouil Markoulakis. I'm a postdoc here in the Hellenic Mediterranean University. And after this short trailer of my new research, I had like to present an outline of my research, which might be very intriguing and put some new ideas and contribute some new ideas in the science community. So the topic here is the vacuum. The vacuum is the third player in our universe. We have matter, normal matter, light, and then we have the vacuum. But the vacuum is mysterious because we can also see it practically. It differs from normal matter and light. It has some fundamental differences. And we here, with this research, I exploit some not so seriously taken possibility, namely a property of the vacuum that we will discuss later, and it's obvious from the title here what this property might be, which however just assigning this single attribute solves many mysteries, cosmological and also quantum mechanical. So I think it's worth to and grants more investigation about this matter we are going to discuss today. So the vacuum, before we go to the vacuum, we of course as you will already think, already have known, we assumed it's not nothing, but it's some kind of energy which however fundamentally differs from normal matter and light, and I believe that's practically obvious. So before we go to the main topic, we have first to discuss something before that. So maybe it's not very known, but in a static magnetic field or in an electric field, the flux lines here, the magnetic flux or the electric flux, these are not made up of photons, of normal photons. Quantum field theory says that these are the so-called virtual photons, but no one knows really physically what these are. So this might be distortions in the vacuum. So this might be actually distortions of this zero-point energy, which we call it zero-point energy, but it's not a zero value. It's actually a non-zero, a small value. We can observe more on this later, and this might be actually distortions of this zero-point energy vacuum energy manifested as a virtual photon. So this here, the magnetic flux lines are made up of virtual photons, not normal photons. And we can better understand this field created by saying that the magnet apparatus here is not creating actually the field, but is actually distorting the vacuum energy. And the same we can say for the flux of an electrostatic field. Yes? So if there are not normal photons which are making up the flux of these fields, of these static fields, so what is then a photon? So according to quantum field theory, a normal photon is a point-like excitation in the quantum scalar virtual photons field that permeates all space. So we can actually, another interpretation of this, of the above, we could simply say that it's a point-like type of distortion of this omnipresent vacuum energy. So, but what is this vacuum energy, and why we cannot directly observe it, but only can detect its distortions as electroweak, strong, and gravitational interactions, namely the four known forces? I think we have to dive, for this we have to dive much deeper and actually go to the about a decade ago, actually more than a decade ago, at 2012 of the CERN LHC experiment announcement. 4th of July 2012 was the official announcement of the detection of the very possible 4.9 sigma significance detection of the Higgs boson. So what the scientists did and engineers did in this very famous experiment, I'm not referring to the God particle, but this is silly, but yes, it's a very fundamental particle. So what they did actually, they were trying to detect the vacuum particle, the elementary vacuum particle. This is actually very known. So they collided two proton beams, two matter beams, which had a kinetic energy each of 7 tera electron volts, coming from opposite direction, and they collided to a point. With this interaction, it's not actually, don't imagine billiard balls colliding, but the protons, the two matter beams were consisting from protons, and the gluons inside the matter field of the proton with the quarks, when the two protons come very close together, one gluon of each proton interacts with one gluon from the other proton, and this gives a spread of all kinds of other particles which are detectable. But they were interested for one specific type of interaction, namely the production of two photons flying in opposite directions. So here we have the two matter beams. This actually symbolized here, shown illustrated here. Here an angle up right and up left are coming the two matter beams, and then we have two opposite flying photons from the collision point. So what they actually did is to make an imprint of the fundamental particle of the vacuum, of the hypothesized fundamental particle of the vacuum, by imagining that if the vacuum is, say, some kind of glass or the windscreen of a car, and you smash at a point, you make an impact here of the two very famous coming this in very forcefully. The two matter beams impacting here to a single point, a very small point, and the energy, the impact energy, imprints this God particle, the Higgs boson, makes the imprint, and this is here depicted, illustrated as an analogy here of a smashed at a point windscreen of a car or a glass or whatever. So you can also imagine it that you say something drop very violently inside a water surface, a small stone, and you create ripples. You create wavefronts which are transverse to the propagated energy, and also this is the transverse waves, and this radial here beams are the longitudinal waves produced by this impact. So we have an analogy here, simplified water analogy. If you throw a stone on the calm surface of a water pond, a lake or something like that, then actually the molecules are making circular motions on the surface, and as we go deeper, the longitudinal component prevails. So the molecules are now moving more to the direction of the pointing vector, and lose the Z component, which is the transverse component of this vibration. So this is the Higgs boson. It's a way. It's not the actual thing we want. The scientists want and the engineers want to detect. They wanted to detect a manifestation of the Higgs field, which is the field responsible for giving mass to elementary particles. So what my research reveals is that the Higgs boson was just an artifact and not the actual elementary vacuum, hypothesized vacuum elementary particle, which we call graviton. So what was behind the Higgs the Higgs boson was actually the decay of a graviton. That is what my research reveals. So what exactly was happening here, according to my research? So it's known that the Higgs boson, which has a mass of 126 giga-electronvolts, is a particle which has a spin 0. But spin 0 is a very unnatural spin. Spin 0 means that the particle is not there actually. It has no rotation. There is nothing there there is no particle which has not an intrinsic vibration. Spin 0 means it has no vibration, which is and it has no any manifold, any size or whatever. We know that the standard model actually says that all the elementary particles are dimensionless point particles, but there is actually ongoing research for finding a finite size, a limit of these particles. So if these particles are Planck size, in the scale of the Planck, we cannot say they're dimensionless, which is a mathematical actual description, very convenient man, but it's not observed nature. Nature actually, things in nature have size and specific shape. So what my research is saying, it's that you have here the Higgs boson, which has a spin 0, which is a very unphysical spin. But this here, and when you hit the two matter beams coming here and here, you eject two photons were ejected. Photons have spin 1 in opposite direction. So this photon has, say, spin -1, and this has a spin 1. Each of these had 63 giga-electronvolts, so this gave us the mass of the Higgs boson. But exactly because the spin was 0, it has to translate after the decay of the Higgs boson. It has to decay to two opposite spin photons. So you have spin +1 and spin -1. That gives the final spin 0 of the detected Higgs boson. And in order to have this kind of reaction, you need opposite direction. You need the two gamma photons, very high energy gamma photons, flying in opposite directions. The photons, I believe, if I remember correctly, were detected by the Atlas detector and also CMS by calibrometers, by the thermal signature, and this demands an angle of 180 degrees. So this is the spin 0 actually. This was the unique fingerprint of this interaction for finding the Higgs boson. You had to have two flying opposite spin plus and spin minus gamma photons at an angle of 180 degrees. That results from the decay of a spin 0 boson, because, as I said before, spin 0 you have spin 1 and spin -1 normal gamma photons, which results to the total decayed spin 0 of the Higgs boson. So what now I have researched and believe that is very possible. So the detected actually particle, behind so this was just a collision point. The collision point was imagine it like a snapshot of the impact or a snapshot of the graviton. So you have these two very fast matter beams, and they collided, and they took actually an impact, a static imprint of what was actually the real vacuum elementary particle, which I believe is the graviton. So the graviton, you have the graviton, according to our theory, is actually a spin 1 photon, but which has a revolution, a rotation here. Imagine like a bike wheel that rotates at an angular frequency with a tangential velocity faster than the speed of light. And we will see, we will discuss later how is this possible and how you can have something faster than the light. Imagine, remember, I would like to remind you that special relativity and the speed of causality, namely the speed of light, limit c, concerns the matter and light, the interaction and the motion of matter and light inside space, but space-time itself can be whatever he likes, whatever it likes. So space-time, the fabric of space-time, which we say it's the vacuum, the zero-point energy vacuum, is not restricted by the C limit. And in that sense, if we assume that the vacuum is now quantized and consists from some elementary quantum vacuum particle, unknown particle, this also has not is not obliged to obey to the C limit. So the graviton, the Higgs boson, came out from was a static imprint, a collision imprint of the Higgs boson was the static imprint actually of the real fundamental particle of the vacuum, which our research says it was the graviton, which is a photon. Topologically, the photon is a spin 1 can topologically depicted as a ring, as a circle, which however revolves for the case of the graviton at superluminal speed. Please don't be confuse this with tachyons, which there the superluminal speed is referring to translational motion through space. Here we have vibration, we have rotation actually, and the superluminal we have in place. Imagine the vacuum to be a lattice of all these elementary graviton particles. More like a better description would be a condensate of these graviton particles, and all these particles in place, vibrating, rotating like a wheel at superluminal speed faster than the light, faster than the C limit. Okay, so this is the graviton, but what happened actually? We believe the decay of the graviton is to the Higgs boson was more or less a phase transition. Namely, the graviton, due to the impact of this of the two matter beams, this violent impact, the graviton has loses his vibrational, in place vibrational energy. Again, I'm not referring to tachyons, just vibrational rotation, the angular frequency here, and came to our space-time, losing his initial superluminal energy state, which makes this vacuum energy totally invisible and undetectable by our apparatus. But because this violent here collision of these two matter beams and producing the static imprint of the graviton, which is the Higgs boson, according to our theory, the graviton loses his energy and comes to our space-time. It becomes luminal. So by becoming luminal, we have the release of these two photons, which are equal energy with the Higgs boson. They actually impact that produced that manifested the Higgs boson in the experiment. So, but why we have two photons? why a single graviton and decays to Higgs boson, and then the Higgs boson decays to 2 photons. The formal explanation, of course, is because it has spin 0, and therefore it has to produce 2 opposite flying spin photons. But what our research shows is that this actually is a very known superluminal relativistic effect, which is called relativistic image doubling effect, which is a superluminal effect we can observe when we have a photon which comes from a medium with a refraction index of 1, so it's actually vacuum, say, and goes inside a medium which has a refraction index larger than 1, which means that light now is slowing down from this material. Then if it has a very high momentum, which have actually in the example here is in cosmic rays entering the atmosphere from space, if the photon has initially a very large momentum, it will not immediately go to the slower speed, but it will be a very small instant in time which will it actually decelerates. So from c speed it goes to a smaller speed, but gradually. Okay, here gradually it's just a few maybe picoseconds or attoseconds. That's it, you know. So during this phase, where the deceleration of the photon, namely, then we can observe a very known experiment, a very known phenomenon, the image doubling effect, which is actually a real effect. It's not an apparent effect, and that is an observer will see the photon. If we could see a single photon, a photon flying towards the direction, the initial direction, and a photon flying from the same point, from a single point, to the opposite direction. So this is a superluminal effect, and we believe that was what the Higgs discovery was, and the 2 photons observed was actually the relativistic image doubling effect, which is what is this saying? This is inferring actually very strongly that the vacuum is a superluminal energy, an unknown type of superluminal energy, and that is the fundamental difference between normal matter and light. My research shows. So the relativistic this superluminal relativistic image doubling effect. I'm not saying that this is due to this effect, yes, but we can actually have a picture of this, a similar picture, which can be used as an analogy. Here we have in the upper atmosphere the phenomenon, the known phenomenon, which is still, however, not explained fully, of sprites. You know, this lighting which comes like a balls. It's starting from a point, and you have simultaneously two cones coming out from a point, going to opposite directions. So, and you can also hear the Doppler shift effect. Here the light is coming towards the Earth, and it's having the blue color, similar to Cherenkov radiation. And here it's going up, the light is going away from the observer, and it gets this red frequency shift. So you have a Doppler effect here. So we say that what we actually have seen in the Higgs experiment, the detection of the Higgs boson, was a relativistic superluminal effect, which actually says that the vacuum is a superluminal energy. It's a manifestation of superluminal energy, and you can imagine this like that, like the sprites. This actually was an actual photographed from a high altitude from an aircraft. So So let me now, we're going now to show that actually the spin 2 of the hypothesized, actually also from the standard model but not yet discovered graviton, the spin 2 property, which actually translates to a p symmetry of this particle, is an impossible relativistic spin according to special relativity, unless this particle is superluminal. So it's equivalent with a superluminal spin 1 photon. Our previous research, in a previous research, we have constructed a topological fiber model of the electron half spin, a topological model for the illustration of the half spin of an electron. And we can see that here. This is actually the spinor model with the 4 pi symmetry of this particle. So each point here on the fiber returns after 2 full rotations to the initial place state in space. So the spinor, the electron spinor, the half spinor of the electron, which is illustrated here by this fiber model, topological fiber model, returns after 2 rotations. But our research that this actually is a relativistic effect. So the spin, the 4 pi is in the frame, inside the frame of reference of the electron particle. The symmetry is actually 2 pi, but because you will have the spinor here, which has these ratios of the lengths of the spinor, so it has an z-axis rotation in superposition with the equatorial rotation, as we have seen in the animation. And if we select this ratio of the tangential here, the z-axis rotation, which is LR, the revolution, and the equatorial spin here, the length of this spinor trajectories to be 0.866. Actually, the exact value is square root of 3 divided by 2, which is approximate to 0.866 value. And actually this matches these 2 speeds, the tangential speed here of the revolution, latitude revolution here symbolized with VR, and that the equatorial, the longitudinal revolution is symbolized with Vs. If the speeds also are this ratio, with Vs being actually the speed of light and VR the revolution speed, sorry, the spin speed, the equatorial spin, the tangential speed be 0.866 of the speed of light, which is the speed of revolution. Then this exact translation of the spinor of the electron gives a Lorentz factor of 2, which actually translates in the lab frame. The experiment is performed with a neutron interferometry of single interaction of a single neutron interference with itself. So this time dilation here by 2 translates in the lab frame the actual 2 pi symmetry of the electron to a 4 pi in the lab frame. So this is fine, this is okay. But coming now to the spin 2, which is hypothesized by the standard model that it's a spin 2 boson. If we now make the same analysis, but with a topological, the boson is a wheel, a circle, which is very rotating with the angular frequency here. But the 4 pi symmetry, spin 2 translates to a pi symmetry, for the graviton, which means it will have it will do a full circle by moving only pi divided by 2. So it makes a full circle, moving only the half circle, which is results to the impossible Lorentz factor of half, which is less than 1, and which is prohibited by the special relativity. So this actually translates not to a time dilation, but to a time contraction in the lab frame. So this is impossible unless the graviton is a superluminal particle, which is what the research here actually says. Our research actually says, because in superluminosity this is allowed. So the graviton, since it's the hypothesized elemental particle of the quantum, which I remind of the vacuum, sorry, which I remind that space-time itself thinks objects of mass and light, their motion interaction is, yes, it's limited by the c limit, by the speed of causality, but the space-time itself, the vacuum, can do whatever it wants. It's not restricted by c. So I believe we're not violating here things, and this will also be more obvious. We're not violating special relativity, and this will be obvious also from the further analysis we will present. So what our research shows is the graviton is a spin 2 particle, which translates actually to a spin 1 photon, but which has a superluminal angular frequency. So it's the frequency is less than the Planck, is more than the Planck frequency. The tangential speed here is faster than c. So some predictions of our theory, of my theory. The graviton spin 2 particle is the quantum vacuum elementary particle and has an intrinsic superluminal V larger than c oscillation frequency. The graviton is phase transition, in particular here now in the case of the LHC experiment and the Higgs boson detection. The graviton is phase transitioning, among other, it can transition to whatever. The Higgs boson cannot, it's not just the 2 photons, it can transition to many different Feynman diagrams interactions, but the characteristic which was used during the detection of the Higgs boson was these 2 opposite flying gamma photons. So the graviton is phase transitioning into a spin 0 Higgs boson, which is actually the impact imprint of a superluminal revolving graviton, which due to the impact of the 2 matter beams was instantly, for a moment, for just a fraction, 10 over minus 21 seconds, or maybe less, to stop, to come to a sudden halt. So it's a static imprint. Actually, the Higgs boson is a static imprint of a graviton, of a superluminal graviton, which was forced to change phase and come to our space-time. The graviton is phase transitioning. That's what I mean by phase transitioning, by deceleration, the sudden deceleration in its angular frequency, which is manifested as a Higgs spin 0 boson, is phase transitioning into a spin 0 Higgs of minimum energy, approximately I believe, if I remember correctly, Atlas reported more to 106 giga-electron volt, and the CMS reported 125 and point something. So about 100 to a minimum energy of 126 giga-electron volts. which following can decay into two opposite trajectory very high gamma photons, very high energy gamma photons. And what our research shows is that CERN detection of the Higgs boson at 2012 by the two gamma photons decay observed was possible as superluminal relativistic image doubling effect, or it's called RID, caused by a decelerated source graviton. So the two matter beings impacted made a snapshot of a hold and stop graviton, which immediately lost his angular frequency, and this was the artifact produced we call Higgs boson. And this graviton then decayed in two steps. First to Higgs boson by the impact, breaking, imagine like breaking the vacuum. If the vacuum is a glass, and you smash the glass point, you make an imprint of that, and the vibration then decayed to the two gamma photons observed and measured in the Atlas detector and the CMS. So continuing now, how we can what experiment we can do actually to verify the superluminal nature of the quantum vacuum. So it's in our theory, in my theory, it's predicted that the two gamma photons initially to be superluminal. That's non-Lorentz invariant and actually virtual photons, and then decelerated to luminal speed c normal photons, which were then detected by the sensors of around. So you have now here the two opposite flying photons, and here around we have the calorimeters, the sensors. So what we can do, we can actually, the verification is possible by very precise possible out-of-seconds accuracy. Out-of-seconds is minus 18 over 10 seconds. And so we need this kind of accuracy, maybe it should be even less, measuring the propagation delays of the two gamma photons Higgs boson decay to the LHC detector sensors. So you know the distance here, and within the limits of the statistical error, you calculate the propagation speed. If you find it to the slightest less than the predicted, it means that initially these two gamma photons were virtual photons and were flying with superluminal speed. And because it came from a space-time where the graviton resides, which is different from ours, in how it's different, it's superluminal space-time. So then it decelerated to our space-time, and then this produced this known relativistic image doubling effect. So we saw the two opposite flying. Due to this, we saw, which I must stress out, it's not apparent effect, it's really real. Yeah, in our space-time, actually there were two photons manifested, but out of the space-time of the graviton came just one graviton decelerated out and produced the superluminal relativistic image doubling effect, which is actually the two photons, opposite flying photons we observe in our space-time, and these two photons are actually real. They are two photons. So maybe actually possible, but this is not quite possible with the current technology. We cannot attain this very fast accuracy, measuring speed of time, but we can compensate for that by making the detector larger in diameter. So increasing this distance will give us the space needed to make the actual time measurement, to measure the propagation speed of these photons. So if the measurement comes out to be faster than the speed of light, this would possible interpretation of this would be that the two photons initially were Richard photons and were traveling propagating with superluminal speed, which is characteristic of the vacuum being a superluminal energy. So now we go to some more practical questions. Why the superluminal vacuum appears to us as nothing, which is not just a philosophical question, but it has actually physical meaning. So why, if this vacuum is assuming that everything, all the interactions are due to the vacuum, have the origin to the all the four forces have origin this vacuum energy, and maybe also possible after the Big Bang or whatever creation event this was, matter and light, we can actually say that this was a phase transition of the vacuum energy, this kind of process. So why we cannot detect this superluminal vacuum energy? And it's totally undetectable, directly undetectable in our instruments, and we can only see the distortions in this vacuum energy manifested as the four known forces: the electroweak, the strong force, the nuclear strong force, and the gravity. So it's possible connection. It's possible. We will now discuss why this is why the vacuum appears as nothing. It's possible connection with dark energy, aka the cosmological constant problem. These are two very close related: dark energy and the cosmological constant problem. Dark matter, the connection of the vacuum with dark matter, which is all these things have to do why the vacuum appears to us as nothing. Its connection, we will discuss its connection with quantum gravity. We have already discussed it in some detail, which is the graviton. Its connection with virtual particles. Remember the initial first slides where we discussed that the static field, the flux, is made from these virtual particles, but not just these virtual particles, but actually the quantum form with science and the standard model says exists in the vacuum. This constant fluctuations of the vacuum energy manifested as virtual particles coming in and out for an instant out of the vacuum. And also the connection, most importantly, the connection with quantum mechanics wide behavior, because we'll see that if we adopt a superluminal property, an intrinsic superluminal property for the vacuum, then many of the wide behavior of quantum mechanics, the wide behavior of quantum mechanics is explained. And this is not because our research, but research from independent sources, the last one. But let us first see just take the normal special relativity Lorentz transformation and see what mathematics has to say. So just plain mathematics, what it actually says in the case of we have something superluminal. So the assumption here is the free space, the ideal zero-point energy vacuum. I'm not talking about the vacuum which has some atoms inside. They say in the stellar space has about 1 atom of hydrogen per cubic meter. I'm saying in the pure physical mathematical way, the pure vacuum, the zero-point energy, about this vacuum, the ideal vacuum, right? Yeah. So the assumption here is that the ideal vacuum is an unknown superluminal state of energy where the unknown yet elementary quanta of the vacuum, possible the theorized graviton at the Planck scale, harmonic oscillate, this quanta of the vacuum, harmonic oscillate in place at speed v, tangential speed, rotational speed larger than the c. the C limit. So again, not to be confused, we are talking here about vibration, or about harmonic oscillation of elementary particles, not of their translational speed. Because our theory believes that the vacuum is a condensate, and the quanta of this elementary quanta of this vacuum are vibrating in place, are not translating in space, they just stay there in place and vibrating. So we are not prone to the limitations of the tachyons. You know about tachyons having negative energy, so they cannot go decelerate, and you have to maintain always speed faster than the speed of light as tachyons. But here we don't talking about tachyons in sense of translational motion. So if we make the Lorentz transformation, that is literally the conclusion of the Lorentz factor gamma calculation. That if we put in the Lorentz factor speed larger than c, we get a pure imaginary Lorentz factor. So the reciprocal of the Lorentz factor is a pure imaginary number. So therefore, the Lorentz factor being a pure imaginary number and not a real number, thus vacuum appearing as nothing. So this is literally the conclusion of the Lorentz factor of the special relativity, that indeed a superluminal particle will vibrating at superluminal speed will appear as nothing in our Einsteinian space-time. So further investigating the question why the superluminal vacuum appears to us as nothing using special relativity, this is further supported by our relativistic topological analysis of the theorized spin 2 of the graviton. We have shown before in the previous slides with this fiber spinor model. Shows it is only possible if this is having an intrinsic superluminal vibration, thus a pure imaginary Lorentz factor that will render it as nothing in a normal space-time. Also, in compliance with special and general relativity, normal matter and light interaction and motion are bound to the speed of causality limit c, the speed of light in the vacuum. However, space-time itself is not bound to c. Therefore, it is a logical thought that if the vacuum is quantized, its quanta should also not obey the c speed limit. So, continuing. So the graviton, the theorized by our research quantum of the vacuum, elementary quantum of the vacuum, is residing to a space-time which is out of phase from our matter-like Einsteinian space-time. So it resides in superposition with our space-time in a different space-like discrete space-time. So we have both space-time coexisting in superposition in Cartesian space, and whenever a graviton, for whatever reason, decelerates, it manifests to one of the four forces, known forces in our universe. Also, a Planck scale or sub-Planck scale in size, superluminal vibration harmonic oscillation frequency, would render the hypothesized quantum vacuum quanta, aka graviton, to a quantum black hole, which explains also, so we can see now also the graviton as a black hole. If we exceed the Planck frequency, which is the maximum frequency which is detectable in our space-time, if we exceed this, if we hypothesize that this graviton exceeds this angular frequency, then this actually renders it to a quantum black hole, to a microscopic black hole, which, however, if we imagine the idea of a quantum for microscopic quantum Planck size black hole, which all the gravitons which are omnipresent in space, it's full of these gravitons. Vacuum space is a condensate of these gravitons, of these microscopic black holes. This actually gives a very good picture of why the vacuum is nothing, because the nothingness properties of the vacuum is created by the singularity of this quantum black hole. So the center here, there is nothing, yeah, there's a singularity. So that's why the vacuum appears as nothing to us. And also, which is the singularity is beyond the event horizon of the black hole, and with a photon ring of the graviton, this revolving energy here, is responsible for creating the non-zero point energy, non-zero value of the vacuum. Yes. So when we see the elementary particle of the quantum as a quantum black hole, which is in so large number, which consists of condensate of these boson-like particles, then beyond the event horizon you have the singularity here, which is nothing, which will appear to our space-time as nothing, and the photon ring of a black hole, which is actually the rotation here, the rotational energy of a graviton, will appear to us as the 0 point energy we can observe in the vacuum. So this actually very nicely ties to how we observe the 0 point energy vacuum as nothing, but also as a small value here of energy we can observe. So sorry very much for this small pause. I was distracted and came back now, and yeah, so we continue now. Okay, so that's the black hole interpretation, the quantum black hole. Let's continue. So now we investigate the superluminal quantum connection with dark energy. That's the cosmological constant problem, and dark matter, and also quantum gravity. So by assuming the graviton to be to have a superluminal intrinsic property, so the vacuum itself has a superluminal intrinsic property, this actually solves the observed cosmological constant discrepancy, namely the worst prediction code of physics, the QED, the quantum electrodynamics prediction of the free space vacuum, that calculates the vacuum density 100, about even more than 120 orders larger than the observed cosmological the observed deduced energy due to the expansion of the accelerated expansion of our universe, of our observable universe. So this actually solves the problems by sampling this superluminal property, because then the missing energy between the actually observed and the QED predicted value of vacuum energy is the dark energy. So the missing energy, because the superluminal property is hidden, this dark energy is hidden energy, and we see only the tip of the iceberg. Yeah, and we observe only the tip of the iceberg in the form of the 0 point energy of the vacuum, the non-zero value of the 0 point energy of the vacuum, and its fluctuations. Yeah, the quantum fluctuations. And why it's hidden? But exactly for the reasons we explained before, why the vacuum appears as nothing. So the dark energy, which was assumed to explain this discrepancy, is actually a hidden energy. We cannot observe exactly because it's intrinsic superluminal property. We cannot directly measure and observe, but it's there. And second, the superluminal spin 2 omnipresent graviton is the elementary quantum vacuum particle, and as well as the elementary quanta of gravity. Yeah? The graviton creates both the dark energy repulsive effect similar to the radiation pressure, responsible for the expansion of the universe, and also macroscopically then, gravity can be explained as a gradient of the number and density of gravitons in normal matter and cosmological black holes, that presumably is of higher concentration than the rest of the surrounding 0 point energy. So this creates a negative pressure we perceive as gravity. So also, what is the connection with dark matter? Dark matter could be explained as a side effect of the gravitons that concentrate more on the boundary of matter objects, aka surface, as a halo, increasing the gravity field of normal matter to a slight percent, which has, however, a significant observable effect at galactic scale. So that's why this additional matter, due to this boundary effect, and this, of course, dark matter is in every single atom. It's around. It's in every. Actually, the Fermilab experiment, in a way, if it's now the muon experiment of the anomalous magnetic moment of the muon, we have the last 2 years in Fermilab, which actually verifies these virtual particles around every. So the vacuum, the quantum of the vacuum, the virtual particles are all around the normal particles we have, like the muon, and they are slightly changing its magnetic moment. So if currently the discovery is at 4.2 sigma, if it gets higher, this also will be an indirect confirmation that virtual particles are real and are coming out of the vacuum. So here this sums up very nice what's going on. So you have here the graviton, which is superluminal rotation here, the spin. The gravity effect, the gravitational forces created here from the singularity inside, after the event horizon. The non-Lorentz invariant part is actually this part of the photon ring, the very energetic one, which is superluminal, and is responsible for the dark energy. We cannot measure directly this energy. This is actually the hidden energy, and we see only the halo of this of the graviton manifold, this halo here, which we will perceive like a 0 point energy and its fluctuations. So this is actually this part is we can say is the Lorentz invariant part, the one which obeys the c speed limit, yeah. But this here, the energetic ring, is the dark energy which creates the repulsive force. It's actually a photon, but it's superluminal. So it has radiation pressure. This radiation pressure, which is created due due to this superluminal rotation higher than c, creates the expansion of the universe as an anti-gravity, as a repulsive force. But the gravity is created by the singularity here of the graviton manifold here inside. So graviton is generating both the dark energy, the repulsive force of the universe, and the gravity. And the number density of the gravitons in the vacuum, and I remind you that the vacuum is not just the interstellar or galactic vacuum and outer space vacuum. Vacuum exists also between the atoms, between the elementary particles. It's everywhere. Vacuum is omnipresent, yes? So, and the halo of the vacuum here is the dark energy noise which the graviton creates, or else we call it quantum form of virtual particles. This is actually here we have a part of this noise of this halo where for a moment becomes goes to the c speed, and we see the virtual particles coming out, and then again fluctuates between c and over c, and then the particles go out of existence from our space-time and popping in, pop out again and pop in from the two discrete space-times, the superluminal space-time and our Einsteinian space-time. And this creates what we call virtual particles, the zero-point energy of the vacuum. So this here ties very nicely, I believe, all three parts of the vacuum phenomenon, and explains very nicely the dark energy connection and the gravity, and also the zero-point energy we observe of the vacuum, and explains the cosmological constant problem. So this here energy, the very bright photon ring, is the dark energy, which is hidden, and we see only the 0 point, the noise, the halo here of this rotation, which is the quantum form we observe of the vacuum, which is much less than the actually energy here hidden inside the ring. And gravity is at the center here, at the singularity of the graviton manifold. So also very important to which very nicely I believe summarize also the first slides we shown about the flux we observe, because one manifestation of the graviton is the flux. The graviton is distorted, and this is manifested to us as electric or magnetic flux. Yes. So besides gravity, the most other fundamental manifestation of graviton's observable effects in our space-time is electromagnetism. So why? Here we have an electric, could be an electric or a magnetic flux line. The flux lines are consisted by quantum vacuum particles, both. Only the curl changes from magnetic flux, from a magnetic flux line to a electric flux line. Actually, in magnetism, the divergence is zero. There's no divergence, so it's close. So it has curl, but an electric field, an electric flux line, we can have if it's a monopole field from a single electron, it has actually divergence zero, whereas in the magnetic fields the divergence of the flux lines is non-zero. Yes. Maybe I have put it the other way around. Yes, the magnetic magnetic flux lines have divergence zero, whereas in the electric field the divergence is non-zero. Okay. Sorry, it's late here. Okay. So the electromagnetic flux is the basis of all electromagnetic phenomena, starting from static fields to dynamic electromagnetic waves. Yes. So what is happening, what our research shows, is actually similar to the Max's view of each point in a magnetic flux line each point in the magnetic flux line be actually a microscopic quantum vortex which all vortices are aligned, and the magnetic flux line is passing through the center of all the vortices. So again here, when we zoom in a point here, in a region here in the magnetic flux line, we will see all the gravitons are coherently aligned with each other, creating created actually the effect here of the flux line. So in a flux line, either electric or magnetic, are actually aligned gravitons, Planck-sized gravitons, which create this distortion in the vacuum. We call electric or magnetic flux, which is again is the basis of all electromagnetic phenomena. And this of course is we call them virtual photons. This decelerated because in order to align, they have to decelerate. They're coming in our phase, in our space-time. So whenever the gravitons, a magnet, which is the disruptor of vacuum space, the vacuum energy, then the field is formed in the vacuum of coherent aligned gravitons, which create the flux of the magnet. But in order to align, these gravitons must come out of the phase, so they must decelerate. So they actually what we see is this here, the noise, the 0-point energy noise, decelerate and form the magnetic flux line. On the noise we see here, the Lorentz invariant noise, which obeys the c-speed limit, is actually what we call then the flux line, which is formed by all these aligned gravitons. So whenever the gravitons align coherently, we have the phenomena we call electromagnetism and electromagnetic flux. So now we're going to the last part, which is the relation of superluminal quantum vacuum with quantum mechanics. So, as I said in the beginning of this presentation, by assigning this single intrinsic superluminal property to the vacuum, which fundamentally is different from our normal matter and light, although the vacuum, although the source of an origin of all of four known fundamental forces in nature, our research shows, through a phase transition mechanism, as we explained, this deceleration, we can explain the apparent weightiness of quantum mechanics, like quantum entanglement, non-logality of quantum mechanics, quantum tunneling, quantum superposition, and quantum, in general, indeterministic nature of quantum mechanics. Yeah? And this is also supported by the 2020 and 2021 Drakan and Eckert papers, which show that by assigning superluminal property, not to the vacuum, but to the vacuum is our novel conclusion. Drakan said and Eckert said by extending special relativity for superluminosity, then all the wide behavior of quantum mechanics is explained. So all explain superluminal interactions in a space like space-time, where most of the energy of the vacuum superluminal energy resides, and projected in our light-time like space-time reality, observed mainly as instantaneous action at a distance. So if you accept that the vacuum is superluminal energy, so its interaction are transferred with superluminal speed, and when this superluminal space-time is projected to our space-time, this will appear to us as exactly how quantum mechanics appears, with all this wide stuff, instantaneous action at a distance, quantum entanglement, superposition, particles is in all the places at the same time, and so on. So my final the message I want to the message to go home with, I want to left is that the benefits are too big to be ignored and grandfather research. We must break off from the speed of light limit. So we cannot ignore anymore superluminal research. It's possible, but because the benefits, as we have shown, are too big, are explaining only by assigning this single superluminal intrinsic property to the vacuum. Many of our unanswered questions in physics today, both cosmological and quantum mechanical, will have an explanation. So this is, I think, too big to be ignored. So yes, this is the preliminary research published in a journal, and I want to thank you very much, but don't go home yet. I'm not finished. Keep watching, because we have another 2 slides more bonus material, and actually the bonus is how we can use outline now these conclusions to make possible FTL travel of positive mass. So what I'm saying is to make a spacecraft, science fiction more now, that is traveling faster than the light speed in the vacuum limit c. So according also to Maxwell, but also inferred by this research presentation, the speed of light c is exclusively dictated by the free space vacuum. So we see here the speed limit c in the vacuum is controlled by 2 parameters, which is the electric permittivity E0 and mu0, the magnetic permeability of free space, the vacuum. Therefore, the speed limit c could be seen as a measure of the resistance of the medium, in the vacuum, to linear motion of mass, cause of inertia. So this similar to friction. So the vacuum, which consists from its elementary quantum particle, is a graviton, is responsible for the inertia effect and for the gravity, of course, because these two phenomena are actually the same different sides from the same coin, inertia and gravity. They have the same cause, which we believe is the vacuum. So the solution for FTL spacecraft, faster than light spacecraft, is obvious. Get rid of the vacuum around the spacecraft. So if we could create, if we could create a shell, creating a finite thickness shell around the ship, ideally of true void. So now we get rid of this medium we call vacuum, which is not nothing. So we create now nothing, or more practically a 0-point energy density lower than the surrounding vacuum. That would allow the spacecraft and its occupants to slide through Cartesian space with FTL speeds, similar to an air bubble sliding almost frictionless through a more molecular dense liquid. So yes, Star Wars, prepare to jump to hyperspace. So how, a few more details, speculations now we are going more to the field of science fiction, but why not? It's fun, and remember, history says that science fiction is first, and then comes the science that makes science fiction real. So yeah, so this spacecraft will have this finite thickness. I don't know how this technology could be created, under what physical laws. This finite thickness layer shell of true void, that will actually displace the vacuum energy, or it can create a lower vacuum energy here on the shell, of the thickness of the shell, which cannot be, could be also a few centimeters. It's not very important to be very thick in 1 meter or so. It could be even actually be millimeters thick, as long as it exists. Yeah. So the problem, of course, here is that because you are isolated from the surrounding vacuum, you cannot have inertia. So you cannot use the second law of Newton of action-reaction to have a propellant here to create forward motion, because you don't have inertia. You will be isolated from the surrounding space inertia. So what's that? So this is not by chance here. Prepare to jump to hyperspace. So what you will do with this hypothetical scenario, you will have a normal propellant drive with chemical propellant or an ion drive or whatever, or maybe a nuclear drive, propellant drive. You will turn it on, gain some momentum, and then you will turn on the FTL drive. And this will, because the initial momentum will propel you to faster than light speed. There's of course another problem, how you decelerate, because then yes, I must here stress out that inside the bubble here there is normal vacuum, because matter and light cannot exist without the vacuum. So inside the occupants, the people inside, will be protected. They will have a normal environment, and also they will not experience any inertia as long as they are inside the FTL bubble here, because they are isolated from the inertia of the rest of the vacuum space. So the problem now is when you decelerate, how you decelerate, because if you traveling with faster than light and turn suddenly off the FTL drive, you will be torn in pieces because the sudden regain of inertia. So what you can do then? You cannot decelerate because you are already in the FTL bubble. There is no inertia to decelerate, to control with chemical propellants your speed. So you calculate initially your coordinates, similar to Star Wars jump to hyperspace. You turn on for just a few seconds or a minute your normal propellant drive, then you turn your FTL drive and up you go jump to hyperspace, which hyperspace is nothing more than this bubble here which is surrounding the ship. So then now if you want to stop, you just control here the thickness of the field, of the displacement field. You make it thinner and thinner and thinner, you weaken it, you make it more close to the normal 0-point energy vacuum. And this will gradually, if you do it very, very gradually, this will decelerate you to normal speed without being in danger to be killed by inertia. And when you go to a very small non-relativistic speed or full stop, then you turn off your FTL drive. So this is what you should do. And the other thing is, when you turn the FTL drive, of course you will become immediately invisible. Yes, because there is no interaction with photons. You are isolated from the vacuum, and without the vacuum you cannot have even propagated photons, normal photons. Yeah. So yes, that was a more humoristic part of the research, but this was a qualitative presentation. It was not so much quantitative. Of course, I cannot calculate how much energy and in what way you could create a shell of true void or closer, smaller than 0-point energy vacuum around your spacecraft. It's not like the Alcubierre drive. The Alcubierre drive says that you shrink space-time in front of the spaceship and you extend it in the back, but it does not make any reference to what exactly happens to the vacuum. So yes, thank you very much. I think I was not very tiresome for you, and you enjoyed some of these parts of the speech, and maybe also gave you one or two more ideas for your own research. Thank you very much. This is Emmanouil Markoulakis from the Hellenic Mediterranean University. Bye.